haven't recorded. So as a side note, if you are approaching test day, or for other reasons need to get a hold of classes sooner rather than later that you don't have, let me know, because I do have almost everything recorded now. You guys know that my take is that that's not the best way to go, but it is certainly a way to go, and it's a lot better than missing out on something. So if that is something that will work for you in lieu of being able to attend live, let me know. So this is a different algebra class than I've done in the past, and I continue to remake my math classes again and again and again because I just don't love them. So some of you guys have done some classes that I wasn't doing before, and therefore you have a bit more of the background than the last time that I taught this algebra to a group. So what I'm going to try to do is fit all of the algebra into one class, which will include the advanced stuff. I will let you know when we do hit the advanced stuff, though, because the advanced stuff is really tricky. It becomes a situation where we're involving 5 and 6 different skills into one, and I want to make it very clear that if you are not trying to score a ridiculously high number, you probably don't need to fret about those if you have trouble with them. On the other hand, if they're kind of easy to you, or with a little bit of work they would be easy to you, they certainly will give you a point. But I do mean a point. This is one of the areas that there is only one possible question, and it's in a fairly narrow spectrum, but unfortunately you have to know about 10 different skills to be able to operate at all within that narrow spectrum, and that's kind of the conundrum. So the first half of the class, we're going to be reviewing some of the more basic concepts of algebra. I will be moving fairly quickly because I know a lot of this stuff is fairly obvious to some of you. Algebra seems to be the skill that is the most understood already by people that are in my algebra classes. So I guess it's probably by far the most recent math that you've done. That said, if you're having a lot of trouble with it and you really notice that you don't have these skills, you'll notice it because I'm going to teach this class like you totally have these skills. So you will know if you are not doing as well as you want to be in algebra. And if that does happen, let me know so that we can work on algebra a little bit more. But I noticed that a lot of my students find it pretty easy and think I go pretty slow. So I'm going to try this with teaching every single aspect of the algebra. Now, I do want to make a slight perspective change, because what I've noticed is a lot of times people kind of know how to do the algebra, but they get tripped up kind of easily. And I think the reason that that happens is you don't have as good of a strategy as you could. Now, you know that I'm always talking in math classes about strategy constantly. And there's also a strategy for algebra. Most people don't really use one because they don't think they need one. But if you implement a strategy for this, you will do remarkably better than if you don't. And essentially what the strategy relates to is where we're going to put our focus. So in order to kind of draw this out, I have the rules of algebra attached to the front of this packet. And the rules of algebra are essentially 3 things. To solve for a variable. So the word solve everywhere else in math usually means that we spit out a numerical answer value. So to solve for a variable means to isolate that variable or get it alone on one side of the equal sign. So that's a little bit different. You don't have to get just a number. You could actually have 3 letters still left in one of your answers and still technically be done and have it solved, because the rule says that you just need to isolate the letter that you're trying to solve for and have it on one side of the equal sign by itself. If you've done that, you've done what you needed to do. The second rule says that we use opposite functions to move numbers away from the variable. And addition is opposite of subtraction. So addition cancels subtraction. Multiplication is opposite from division. So multiplication cancels division. And both of those, of course, have a vice versa to them. And then what you do to one side of the equal sign, you must do to the other side of the equal sign, which balances the equation. So you'll think probably that this first batch of questions is pretty easy, and that's good. What I would encourage you to do here, and I'm only going to give a few minutes to do probably this whole page of problems because I think you guys will fly through this. What I encourage you to do is really implement what's on the first page. If you've got it stapled, maybe rip it off and set it next to you. And I'm saying that because when you get into harder and harder stuff, having that solid, concrete strategy is really valuable. So what I would do, let's say that I'm looking at this first one that says negative 2x equals negative 4. So what I would need to do is I would need to find the letter that I'm solving for. And you could potentially run into a situation where there's more than one different letter. And the problem will tell you that you're solving for one thing in particular. And of course, that would be the thing you want to find. So by finding and isolating and highlighting the location of my variable, I can be a little bit more efficient. So x is what I care about. And what I care about in regards to x is getting x by itself alone. So in order to get x alone, I need to determine what I have that is standing in the way of x on the side of the equal sign that x is on, which in this case is the left. So the thing that's in the way of it is the negative 2. And if you were thinking 2, make sure that you integrate something if it's negative, because if you had negative x, you wouldn't have x solved for because of the negative. So negative is just as bad of a thing as 2. So if I didn't have this negative 2 sitting here, x would be alone. And this is what you should always do at very first. You'll get incredibly fast at it to where you're not even thinking about it. But always find x and establish your location in regards to x so that you can just determine exactly who's in the way. So my negative 2 is totally and completely in the way of my x. And now I need to decide, how is it in the way of my x? So the way that negative 2 is in the way of x is it's being multiplied by x, which in algebra, anytime there's a number just directly up against the letter, that means that it's being multiplied. So they don't put a time sign, they just set it next to it. So negative 2 is in the way of x being alone, which is my ultimate objective, and negative 2 is being multiplied by x, and the opposite of multiplication is division. I want to multiply the entire negative 2. So I need to get rid of all that because I need x completely by itself. I need it positive, not negative. So I want all of this to go away. And then, of course, what I'm going to do to one side, I'm going to have to plan to do to the other. On the side that you do this, it never, ever actually matters what happens over there. So you're always using a function that just cancels itself, whether you're adding to fix subtraction, dividing to fix multiplication, and so on. All you're doing is just canceling the two terms out. So by having a negative 2 here and dividing it by a negative 2, my negative 2's will totally disappear and leave x by itself. So you don't need to account for that side. On the other side, I'm going to have something actually numerical happen, which is negative 4 divided by negative 2. So negative 4 divided by negative 2 is going to be positive 2, because if you divide a negative number by another negative number, it cancels off the negative. If you recognize through the course of this class that you're having issues with your negatives, that is a different class called Math Fundamentals. I do have it recorded. That might actually be one that is good recorded, because if it's holding you up from doing anything else in math where you're bumping into negatives, it's better to get that skill. And I feel like the stuff in that class is fairly simple, but addresses common things that people forget, like how to deal with negatives, how to deal with the order of operations, and how to convert fractions and decimals. So that is something that if you notice a problem with, let me know and we can decide the best course of action to get you that. So this one's going to be 2, and that's going to be my final answer, which is the point at which I have successfully isolated x completely by itself. So I answer 2 here. Now go ahead and do all the way to, for some reason my screen doesn't want to move. There we go. Go ahead and do all the way until you get to this one. So don't do this one here. I will make a quick note, so I will do one other one with you, which is not the very next one, but the one after. It's also important to keep in mind if you have two functions standing in the way. So this time, here's my x, and I have a 2 in the way, and I also have this -4 in the way, or if you want to think of it as 4 being subtracted in the way. So if you have two things, you always want to move the thing that is addition or subtraction out of the way first, then multiplication or division. It's totally detrimental to your problem to do it any other way. So the 4 is being subtracted from the x, and that's causing it to be in the way. So the opposite of that is adding. Again, all that's going to do is just reverse whatever is sitting there. And then that's going to leave me with a -12 and a 2x. So if I add 4 to a -16, it becomes slightly less negative, putting it to -12. And then the 2 is the last thing in the way. That's in the way by multiplication. So if I divide, it goes away, and I end up with -6. So try the rest of the ones on this page, which is the one problem above the one I just did, and then all the way until you get to the 1/4. I'll give you just a minute to do that. You'll probably cruise through there fairly quickly. We'll go over those, and I'll show you how to deal with the fraction. So don't worry about attempting the one with the fraction. Give you one more minute. I don't want to push you through this, but we do have tons of other more fun things to do. If I'm ahead of you at all tonight, you can basically choose between following along and actually answering with me, or kind of paying attention to my explanation, but not writing it down so that you can later execute the problem on your own. You can also keep a piece of paper handy that you can write a particular problem and write its answer, but have it separate from this, so that if you want to meet in the middle and you don't want to write out all the work because you want to do it later, but you also want to have the answer, you can do that as well. Although I will probably just send you guys out the key tonight to this. So again, you know my stance on keys. You guys are adults. All I can do is suggest, based on my professional academic experience, that you don't use a key till you're totally done. But I will send this one out because you will probably get done with the packet fairly quickly. So the -4x equals 16 is fairly easy. So the thing standing in the way is the -4. It is being multiplied by the x. So if I divide, that will fix it. It will make the 4 disappear over here, leaving me with x equals -4. Anytime you have multiplication or division with regard to negatives, if you have two signs that are the same sign, whether they're two negatives or two positives. They'll cancel themselves out and make a positive number. So if you have a negative divided by a negative, it becomes positive. If you have a positive divided by a positive, obviously that would be positive. But if you have one of each, like we have here, and I believe we had on the last one we just did, then you will end up with a negative answer. The addition subtraction is much more complex than that. It totally depends on each individual number. So that would take us to this one, which says negative 3x plus 1 equals negative 8. So we have two things standing in the way. We have the negative 3 and we have the 1. It's much better to address addition or subtraction first. So this 1 is being added to the x. So subtracting it will fix that problem. That will then vanish. If you had negative $8 at the bank and you took out another 1, unfortunately, you would now have negative $9. So a negative minus a positive, or a negative plus another negative, those are two of the exact same thing, will create more negative. And then we have negative 3x, and negative 3 is in the way of x by multiplication. So all we're going to have to do is divide negative 3. That makes negative 3 vanish over here. Now you have cancellation because you have two negatives. So x equals 3. The next one is 5x minus 4 equals negative 29. So again, we've got two things in the way. So we're going to start with the 4 because it's addition or subtraction. So 5x minus 4 equals negative 29. 4 is being subtracted from x. So the opposite of that is addition. If you have a negative number and then you add to it, so if you're overdrafted at the bank and you put a little bit of money in, you'll be less overdrafted. So since $4 is not enough to balance out the entire $29, we will still be negative, but we will be a little bit less negative. In this case, negative 25. And then 5x remains. That means that 5 is standing in the way because it's multiplied by x. So we divide by 5. That gets rid of that. And then x equals negative 5 because you have a positive dividing into a negative. And then the last one that you worked on was the negative x plus 2 equals negative 8. So on this one, the 2 is the first thing that we want to address. That is added to x, so we want to subtract it. And if we subtract, we will become more negative. We will become negative 10, and that leaves us with negative x. If you got confused with the negative x there, if it's got a negative in front of it, then it's a negative 1 unless otherwise stated. So if it's got a number, then that's obviously how much it's negative by. But if it doesn't have a number, then it's negative by a unit of 1. So negative x is not x. It's not the same thing. We would need to divide off the negative 1. If we take negative 10 and divide it by negative 1, it switches the sign, becomes 10. So the very last one, if you did look ahead at it, might have looked a little bit confusing. And I noticed that just about nobody I run into really knows or remembers how to do a fraction one. So I'm going to rewrite this vertically since we usually see these more vertical. So this says 1/4 x, 1/4x equals negative 2. Most people see this and they think of the 1/4 as being something that's multiplying x. That is true to an extent, but there is a much better way of thinking of it, because if you felt like this was multiplying x, that would mean you'd try to divide by 1/4, and that gets really, really messy in a really big hurry. So instead, think of a fraction as division, because it really is. A fraction is an uncompleted, a non-completed, I don't know what the word for that would be, division problem. It's a division problem yet to actually be divided. So 1/4 is being multiplied by x, but you could also put this x up here and say that we have 1x being divided by 4, and that's the better way to think of it. So when you do this, and I'll leave the x where it was because I don't want you to have to change things. So when you think of this, you need to think of division and having an opposite of multiplication. So if you have multiplication, you divide. In turn, if you have division, you should multiply. So if we have the 1/4 x, what we want to multiply by is what we always multiply in a fraction division situation. And that's going to be the denominator. Only the denominator. So when I do this, what's going to happen is this is going to disappear. And you kind of have to trust me on this. I could totally do a huge, gigantic, elaborate presentation. But it always works that way. So I'll spare you that and just ask you to trust me. Anytime that you multiply a fraction by its own denominator, what happens is the denominator itself disappears. It leaves whatever was on the top and whatever's to the right, and that is it. So now, and then don't forget to bring it to the other side. So you still have to multiply by the other side. But again, you only multiply by the denominator, not the whole fraction. And don't try to divide. Both of those would be a lot harder than just multiplying the denominator. So -2 times 4 is -8. And that leaves me with 1x equals -8, which in this case, 1x is truly x by itself as long as that 1 is not negative. So that leaves me solved at -8. Now I'll show you a little bit harder example of that. And you can write this one down and try this one real quick. And that will be 2/3 x. And we'll do equals 15. No, equals 10, sorry. I don't want it to come out to a decimal. 2/3 x equals 10. So try applying what I just said to that real quick, and then I will fill you in on how to make sure you did it right. So the first thing that we're going to do on this one is we're going to multiply by 3. So as soon as you acknowledge that you have division because of a fraction, you want to immediately multiply the denominator off. So that will cause the 3 to completely disappear. Don't forget to bring it over here. That leaves you with the top and the side. So that does leave you with 2x. So a fraction could be a one-step problem or it could be 2 steps. It depends on the context. So 2x equals 10 times 3 is 30. And now again, all you've got to do is divide off that 2 and you'll get x equals 15. So on the next page is the beginning of the multi-step. And again, I want to go through this fairly quickly. You will want to practice on multi-step, and you'll see later in the packet that there's lots of multi-step that have canceling negatives and all kinds of weird, funky things that could cause you to get them wrong. And we don't want that. So here are your basic steps for multi-step. So you're going to multiply or distribute. You're going to combine on the same side. I'll show you how to do this in a second. Just put this list somewhere for now. You're going to combine across. And then, if applicable, your fourth step will be to solve. So just write those 4. When I say combine, I mean combine like terms. So if you need to add that for it to make sense later, do. So the way that we put this into practice, we will look at the second one. Some of them will not have every one of these steps. So if you notice that there's not one of the steps, just go on to the next step. So the first thing we want to do is multiply or distribute. And you're going to do that when you see something that looks like this. Zoom this in a little further. So when you see that there's like a parenthesis where there's obviously a distributive multiplication involved, that is going to be your absolute first step. And you could have anywhere from 1 to possibly 3 of those in the same problem. And you're going to want to do all of them this way. So 2 times x is 2x. And then 2 times 3 is 6. So that is my multiply or distribute step. Then you need to bring everything else down. And the worst thing that happens with these is you either miss a negative because they'll put them in the weirdest of possible places, or you forget to bring something down because you only put your new stuff down and you forget to bring the stuff you didn't do anything with on that step. So bring down your +4, bring down your equal and your other side. Do that with all of them at the same time before you move to the next step. The next step is to combine on the same side. That could be x terms or it could be numerical terms. But if on the same side of the equal sign you have things that can be combined together, combine them according to the signs that are with them. So this is a +6 and a +4 that we just need to add together. And that will make it 2x plus 10. And again, bring the next part down with you. So that is combine on the same side, which again, there could be multiple instances of whether you created it by distributing or whether they were already maybe sitting there. So then what we want to do is we want to combine across, which means we want all of our x's on one side of the equal, and we want all of our regular numbers on the other side of the equal. You can do that in either order, but I strongly prefer doing my x's first because then I can choose a direction or a mechanism of action that keeps my number positive. So I've got 4x, and then I can subtract 2x. Remember that just like with other things, that's going to make it disappear. You're going to add and subtract across. You're never going to multiply or divide, because if you multiplied or divided, it would pull the x off of the number, and we don't want that. We want to move the number and the x for the time being. So if you have a negative x value, you can add it to the other side. If you have a positive x value, you can subtract it off of the other side. So 4x minus 2x will leave me with 2x. And once again, I need to make sure to bring everything down with me. And I have one more combine across step, which will be my numbers, and that's the opposite process. I always do my x's, then my numbers, because that keeps me from making my x negative, which again can be reversed without a problem. So don't stress about it if you have trouble doing it in the right order. But if you can do it in a better order, it might save you a little bit of error possibility later on. So now I can add my 3 over here. That will make a 13 equals, and then this will be 2x. And all I have left to do is divide by 2. Dividing by 2 will make that vanish, and we'll say that 13 over 2 equals x is my answer. Most likely, I would need to make that into a mixed number. Hopefully, you've had a chance to take the fractions and mixed numbers class. If not, that's a really important class to do unless you happen to be one of the 2 or 3% of people who's excellent at these, because you will run into these situations a lot. Algebra is one of the places you'll run into them and when you least expect it. So if you have taken mixed numbers, you're going to take 13 divided by 2. 2 will fit in there 6 times, which leaves us with 12. And when we subtract, we get 1. So it becomes 6.5. I can't focus on mixed numbers in this class because we'd spend forever on it. So if you've never seen those conversions happen, just plan to take that class. If you have seen them, hopefully you are moving this fast by now anyway. So now we will go ahead and move on to the next page. Take a quick look at just number 1 on the very next page, and you'll probably find that you kind of run into an issue, but I want to give you a chance to do that. So you run into the problem of, and a lot of people can't quite figure out exactly what the problem is. But essentially you have a reversal of steps, and that's what most people acknowledge that they run into here. So normally you try to add and subtract first, and you don't know how seriously you're taking that idea until you bump into something like this, and you realize that you completely freeze when you can't do it in that order. And that's exactly what's happening here. Is you've got this -8 preventing us from being able to really do anything. So you got the -8 trapping the addition or subtraction in. I'm going to make this bigger. So what we want to do with this, and by the way, label this because you might ask me about this later in lessons possibly, is this is a complex equation, and it's complex because the work is a bit harder. So all we need to do with a complex equation is we need to supersede our normal order to get rid of the thing that's trapping everything else. Now, your fraction process should help tremendously with this. because all we really have to do is we just multiply off the denominator. So this doesn't look like 1/2, but it operates just like it. This is division. -8 is dividing h, which is what we're trying to get alone. And by multiplying the same -8, we can solve that problem entirely. So now we're going to have 29 times 8 over here. Those are both negative, so you're going to end up positive 232. And that's going to equal h minus 6 because, again, multiplying by a denominator just makes it disappear. H minus 6 remains, and all we need to do is just add 6 because 6 is being subtracted from h and is therefore in its way, and that leaves us with h equals 238. For the sake of comfort with those, because those are definitely tricky, do the one right next to it, which is number 6. It says 14 plus r over -11 equals 23. Try that one real quick so that you can get a little bit of extra practice. And basically, you just need to start to recognize division and think of it as division when you recognize it. And that will get you through problems like that. If you have a problem like you see here, this is back to traditional because I can subtract this 29 first, then deal with the 5/8 second. So only when we have a division that is stuck do we have to actually change our process at all. So try number 6 next to the one we just did real quick. So what we will do in this case is multiply the -11. And by multiplying the -11, it will vanish from here. And over here, it will create a -253 because 11 times 23 is 253, and you have one negative. So that leaves you with 14 plus r equals -253. Now we can subtract this 14. That's going to cause our number to become more negative, which will be -267. Keep practicing the complex. That's one of the things people like the least in this particular class. And that is essentially just a block to the normal steps that you take in the normal order you take them in the process. So it's just a matter of looking at each problem uniquely and figuring out what you will have to do first, even if it's a little outside of the traditional way to do it. There's another multi-step solving practice page here, and these ones have lots of canceling negatives. These ones are pulled almost directly from what the test looks like. So these are problems that, to my best recollection, I took when I took the test, and I copied them onto here. So those are ones that you will want to pay particular attention to and try really hard to really zone in to where you're accurate the first time you do one of those. The next page has to do with writing out expressions. And there's a few different forms of writing out expressions. So the easier page is the one after that. So flip one more page. We'll go backward to the other one. And let's do to here. So try these. Most people can kind of nail these down on their first attempt. Give these a try. And I will tell you what they are in a minute. So on the next page, do up through the one that says the quotient of 20 and a number. If you struggle with any of those, no worries. I'll go over them in a minute. So the first one, a number decreased by 92, probably the biggest challenge people encounter with these is making sure you're in the right order. Subtraction and division have a very particular order that they need to go in. Addition and multiplication don't. So 2 plus 3 or 3 plus 2 is the same thing. 2 times 3 or 3 times 2 is again the same thing. However, it is important when you are practicing to try to match up the way that they have something worded with what order it would technically go in, because that's excellent practice. The first one does matter. It's a number. So a number is always going to be X, because we obviously don't know what the number is, or we would have said decreased by 92. So we subtract 92. The sum of 89 and a number would technically be 89 plus x. The order doesn't matter, but it does have the 89 as the first part. A number added to 36. So a number added to 36 is 36 plus that number. So when they say added to, that would be the second piece of it. So a number is being added to 36 that's already sitting there parked. The sum of a number and 26, x plus 26. The difference between 46 and a number, so the difference is subtraction. The difference between 46 and a number will have 46 first and the number second. The sum of a number and 43, so that is x plus 43. The quotient of 20 and a number is 20 over x. So quotient is division, difference is subtraction. So if we go up to the one above, I'm just going to point out a couple of them. First of all, these do say, what is the number? So let's do this first one just so that we can get a little bit of a warm up, and then try the two after that because those two are a little bit trickier. I'm not going to give a ton of time on this because we've still got several things to cover. But take a quick look at them because these are ones I always get asked about, and I will tell you how they are set up. So the first one, 1/2 of a number added to 3 is 4. So 1/2 of a number is 1/2 x. Added to 3 is 4, and is means equal. And then they are asking you what the number is. So the first thing that you would do is subtract the 3, leaving you with 1. And then you'd have 1/2 x equals 1, and you would multiply by 2. And that would tell you that x is 2. The next one is interesting because you don't have the whole story. So it says, Jamie collects bouncy balls on Thursday. She buys 4 bouncy balls to add to her collection. On Friday, she buys an additional 2. On Saturday, she divides her collection amongst 3 of her friends. So this is actually what a complex equation looks like when it's being written, because we know that on Thursday she buys 4 bouncy balls and Friday she buys 2, but we never knew how many she actually started with at all. We do not have information on how many she had before she started buying them or at any point during buying them. So that will put us with an x plus 4 plus 2, but we can't really solve that until we've gone through the entire word problem. So on Saturday, she divides her collection amongst 3 of her friends, and each receives 4 bouncy balls. So the interesting thing about this is until we have the entire thing put together, we don't find out what it's set equal to. It's set equal to 4, but it's set equal to 4 when we've not only added to the collection twice, we have also divided the collection up. So everything has to be in there. The only thing you can simplify is you can make it x plus 6 instead of x plus 4 plus 2. And that essentially solves the entire thing. So now all you have to do is solve it as a complex equation. Multiply by 3. That gets rid of that. X plus 6 equals 12. We subtract 6, and x equals 6. And then the last one you could probably figure out from a standpoint of what the answer is, but they ask for an equation. And oftentimes when the TEAS asks for an equation, they are asking for the actual equation, and you'll have to be able to recognize it without it being solved. So Joseph rents a car. He pays an initial renter's fee of $30. He also pays $1 for each mile he puts on the car. In total, he spends $200. So most people take the 200 and they subtract 30 and then they divide. The way that you would technically do that is you'd have $1 times X, because we don't know how many miles there are, plus 30. So $1 per mile plus the $30 all adds up to a total of 200. So that would be your equation, which you would then solve by doing what I described. So 200 minus 30. So we went 170 miles. So moving on down, don't worry too much about this adding and subtracting linear expressions page. You can give that one a try. And the evaluating expressions is something that is pretty specific to the HESI. Essentially, with evaluating expressions, you want to make sure that you're following order of operations, and you want to take that very seriously when you reach problems that are a lot harder because of that order of operations being followed. And that's what you'll see on number 11, number 12, and one of them down here, I want to say it's number 10, but I could be wrong, is that'll actually create the a fraction in the early part of the problem, which is a huge pain, but that is how you have to solve it. So that concludes the independent algebra packet. That concludes the big bulk of material that you will have for the TEAS test. So most of your algebra questions will be in that category. Lots of weird little tricks that you could easily fall for and things like that. So it's a lot of practicing to be really good at it. Make sure you're good with the fraction showing up in a problem, and make sure you're good with all the canceling negatives and so on. If you do want the recorded version of Math Fundamentals, let me know, and I'll try to offer it sometime in the coming couple of weeks so that you can get a little bit better of an idea of some of those footholds if that's where you're struggling. The more difficult part of algebra is very limited. So you can kind of evaluate this, see if it's easy, medium, or hard. If it's hard, definitely abandon it unless you're trying to score 90 or higher. If it's medium, give it a little bit of a try for a bit. And if it's hard or if it's easy, then obviously go with that because you will get a point for this. So in addition to equations, we also have possibly an inequality that we might run into. And I'm going to go to the second page of the packet because this is a little more encompassing of everything that's involved with these. So an inequality is a situation where instead of it saying that some particular part of some particular equation is equal to a particular value, which is what everything we've seen tonight is, instead it's going to tell us that it's greater than or less than a particular property. That means that what we're going to find is a range of possible numbers for x instead of an actual answer. So if you run into an inequality situation, you're going to follow very similar rules to if you run into an equal sign, but ultimately your answer is going to be very different because your answer is going to say that your x value is greater than 4 or less than 2. So you have no idea what the value actually is, but you do know that it's greater than a particular number or less than a particular number. So here's the rule. You're going to solve these like they have an equal most of the time. So solve them like they have an equal sign most of the time, unless you end up multiplying or dividing by a negative number. And I'm not saying you end up multiplying a negative or you end up dividing a negative. I'm saying you multiply by a negative or you divide by a negative. So you actively take a negative number and multiply or divide the opposite side of the equation with it. So that only happens essentially if you have a negative number next to your letter and multiplying or dividing your letter already. Otherwise, we kind of ignore the fact that it's an inequality until the end. And at the end, we will sometimes find that we have to shade a range onto a number line to show our answer rather than just giving one numerical answer. So the way that this looks, let's look at 13 first, which is actually the first one on here. There's not another page. So this one does not have a situation, and you'll discover that if you can't see it right off the bat, where we're going to multiply or divide by a negative. Now, as a side note, if the mouth opens toward a value, then that is the value that is bigger. If it opens away from a value, then that's the value that is smaller. So the mouth opens toward what's bigger. You probably heard an analogy at some point that semi-stuck with you that basically the mouth of the alligator will eat the bigger food supply. That still holds true. The only thing you have to add on to that is if it has an underline, then we also have the equal to. So it also could be equal to the number instead of just being greater or less. So we'll look at that a little bit later when we've got something kind of to look at with those. So when we look at our equation, we're just going to start like we always do, and we're going to solve like we always do until the point where we run into that situation where we multiply or we divide by a negative. So in this case, I've got a 3 preventing x from being alone, and it's preventing x from being alone as a division of x. So I just multiply x off, and that makes, or 3 off of x, and that makes x over here alone. I leave my sign alone, and then -2 times 3 is -6. This is my final answer. This is my final solution. So I did that exactly the way I would have done it if it had had an equal sign. So when I go to show this on my number line, I'm going to show x, and I'm going to show what x might possibly be in the context of my number line. So the way that I'm going to do that is I'm going to put a point where this number is. Now, the point would be open if there wasn't an equal to, and it would be closed if there was an equal to. So I'll explain that a little bit further. So if it's x is greater than or equal to, or it's x is less than or equal to a particular value, then it actually could be that value. Whereas if it's just x is greater than -6, then it literally means x is greater than -6, and it can't be -6 because -6 is not greater than -6. So in this case, I have x is greater than or equal to -6. So I'm going to shade. I'm going to do a closed dot because of this underline right there. And I'm going to shade from the -6 to the end of the number line. And that will show what my x value might be. All of them are going to work that way. And again, I will send you the key so that you're able to solve these and make sure you're getting them right. We are going to go down to the bottom. There are 2 problems at the bottom that actually do have the negative that multiplies or divides. It's not super common. And we're going to look at what happens if we do have that situation. So let's look at number 22, and I'll write this bigger over here. So this says right now that 27 is greater than or equal to -9r. So now what I need to do is just get rid of my -9, and that would get r alone. But I have an inequality, and I am going to end up actively dividing by a negative when I do this. So when I do divide by a negative, I need to immediately stop and make sure that I flip my sign the opposite direction. Make sure you do that right away because you will forget to do it. So I'm going to leave my numbers where they are, or that will defeat the purpose of flipping the sign. But I'm going to put the numbers on opposite sides of the sign because I flipped the sign over. So if I divide 27 by -9, I get -3. And then by dividing off -9 over here, I get r. So now I have r is greater than or equal to -3. The fact that I flipped the sign is completely and totally because I took a -9 and divided by it. Whether or not this comes out negative does not matter. And whether or not something is already negative that we're going to multiply or divide, again, doesn't matter. All that I do that for is if I do this right here and it's negative when I go to make the movement. So again, I put this onto the number line, and my number is -3. I do have the or equal to, so I will use a solid dot. And I always want to look at my letter to figure out if my letter is greater or if my letter is less. And because of the sign flip, my letter is greater, which will be to the right. And then we'll do one more, which is number 24. So 16 is greater than or equal to -4v. And all I need to do is get v alone, and the only thing in the way of v being alone is -4. So how I'm going to go about doing this is I'm going to divide -4, but because of that, I'm going to have to flip my sign over the opposite way. So again, it was facing that way. I'm going to face it this way. It just goes the opposite direction of how it was faced before. We don't change whether we had an underline or not. We don't change any other property. So that would leave me with v over here because that reversed everything else. And then 16 divided by -4 is -4. And once again, my number over here happened to turn negative, but that is not why I'm flipping the sign. I'm flipping the sign because I multiplied or divided by a negative, because that will change the sign everywhere else in the equation. So that causes that. So if I'm representing v, I'm going to put v at -4. It does have the underline, so I will have a solid dot as opposed to an open. And v is greater, so again, we go to the right. You have lots more of these to practice, and you can always draw a number line if you do need one and it's not there. So one more thing that we need to look at is absolute value equations. So an inequality is just like solving a normal equation, except if you multiply or divide by a negative, then you flip the sign over. It's best to think of it very, very simply like that, because that's basically the entire premise. So unless you multiply or divide by a negative number, in which case you'll flip over the sign, you act like it's a normal equation. If you try to memorize it as entirely its own process, you will most likely get really confused, especially when we start introducing a third thing. This third thing, and again, you might want to label this, is absolute value. So absolute value, just in general, what the term means is it means the distance of something from zero. What that means if we're going to solve an equation, so if you've ever seen an absolute value before, you've seen it like this, and they'll ask you what that equals. So if I have a -4 that's inside of an absolute value symbol, then it's not really a -4, because the absolute value just expresses how many movements I am from zero. So whether I go to the left, which is where the negative numbers are, or whether I go to the right, which is where the positive numbers are, is irrelevant to how many movements I will make. So if I'm standing at a 0 on a number line, then whether I move left or right doesn't matter. I'm still going to move 4 times. That's the absolute value you probably remember. They can put it, however, in a regular looking algebraic equation as well. And when they do that, what you will find is that you have to do, again, another little adaptation that changes it around a little bit. So if I have 3s plus 24 equals 22, then basically I don't know whether my 3s plus 24 is to the left or to the right of the 0. So what I have to do when I solve an absolute value equation is I have to have 2 different solutions. So I have the one that's already there, and then I have another one, and I'm going to keep everything the same, except instead of 22, I'm going to put -22. So instead of 22, I'm going to put negative 22. We only can do this if we have the absolute value totally isolated on the side of the equal sign that it's on. So not everything qualifies to be set equal to the opposite value. So for example, if we look at the one to the right, we've got a 7 right there that's outside of where the absolute value signs are going through. So until we've moved that 7, we can't set two of them equal. So what we would have to do is we would have to determine how is the 7 standing in the way of the absolute value brackets being alone, and that is by multiplication. So all we need to do is divide that. Then we can set two equations. So C plus 6 equals 14 divided by 7 is 2. This is our new equation, and this is what we're going to use for our second setup. So C plus 6 equals 2, and C plus 6 equals negative 2. So I'm not solving these because you guys fully well know how to solve algebraic equations. I'm showing you the setup because that's where it varies. So the inequality varies if you multiply or divide by a negative number, and the absolute value varies in that once you've isolated the absolute value completely by itself, you need two different equations. We do the same thing with 2 because we've got this 17 in the way. So first we need to add the 17. 18 plus 17 is 35. So 7b is 35 and 7b is negative 35. Now you might be noticing when I do the second equation, I am removing the absolute value signs because all the absolute value signs are there to tell us is that we need a second equation with the negative equivalent. So once I do that, then I can just eliminate the absolute value signs. So number 7, which is to the right of this one, is 6 is on the outside and it's in the way. So we're going to divide that first. That will give us h equals 8 over 6, and h equals negative 8 over 6. That will not solve out without being a decimal, so you'd probably make a mixed number. But again, once we get everything alone that's in the absolute value, then we just make a negative and a positive version of it. If we look at number 7 and number 8, not number 7, number 3 and number 8, these are in weird order. If we look at these two, they are already ready to be separated out because they only have the thing that's within the absolute value. So this one's ready to be negative d minus 4 equals 16. Negative d minus 4 equals negative 16. This one's ready to be negative 7f plus 21 equals 15, and negative 7f plus 21 equals negative 15. So keep practicing on those, but again, it's not my big key point, nor is inequality. My big key point is when they combine the two of them together, which will also practice a lot of the same issues. So when you have an absolute value and inequality, you're following both of the extra rules simultaneously. So you're basically just acting like a normal equation, except you have to follow extra rules. So the center of this is going to be the absolute value piece, because we have to get the absolute value alone, and then we have to separate into two different values in order to do that. So the first thing we're going to do is work to get the absolute value alone. If in the course of working to get the absolute value alone, we happen to multiply or divide by a negative number as a coincidence, then we need to flip the sign according to inequality rules. If we don't run into that situation, we will run into that situation automatically when we do actually get the absolute value isolated, which I'll show you. So here, if I want to get x plus 2 alone, because it's the thing that's in the absolute value, I've got a 3 in the way and I've got this 4 in the way. Just like normal algebra, I want to add the 4 first before I divide the 3. So that is going to leave my sign alone. So adding does not change my sign. And that will make that a 12. And that leaves me with 3 times the absolute value of x plus 2 is greater than 12. That was according to totally normal algebra. Now I need to divide this 3 off because it's in the way as well. And again, that's going to be according to normal algebra because dividing by a 3 does not violate either set of rules. So x plus 2 is now greater than 12 divided by 3, which is 4. Now I have my absolute value alone. So you want to isolate your absolute value. I'm not going to put the inequality thing because it applies to more than one sector. But if anywhere, if anywhere during anything that you're doing with one of these, you multiply by or divide by a negative number, you will flip the sign an unlimited, unquantifiable number of times, however many times it happens. So isolate your absolute value. And then when you do make the second value that we make for absolute values, you are going to have to flip the sign over automatically. So what we normally do when we get here, if we don't have an inequality, is we do x plus 2 is 4 and x plus 2 is negative 4. But magically changing a 4 into a negative 4 by pure magic like that, that is multiplying or dividing by a negative. You just switched the sign, and the way that you would have switched the sign is to multiply or divide by a negative 1. So you're going to automatically flip the sign. So every absolute value problem will have one sign flip at minimum, and that will be when you reach the point where you split to two equations and you create a negative version. So the negative version that you create will in fact have the sign flipped. Now I go on about my solving, and once again, I just keep an eye out for a situation where I multiply or divide a negative. So x plus 2 is greater than 4. I need to subtract 2. That is not one of the things that will cause a sign flip, so I get x is greater than 2. And over here, again, I subtract 2. That will cause x is less than negative 6, which also does not have a sign flip. Now I have two values that are represented, and I'll end up showing both of them on the number line. So there's three possibilities for how those would show on a number line. They would either both be like one is greater and one is less than a value, and they create a closed range together. Or they would each go opposite directions and leave a middle space open. Or potentially one of them may cancel out the importance of the other. For example, if you say that x is greater than 2, then you don't really have to say that x is also greater than 4, because being greater than 2 would imply you're greater than 4 as well. And that would cause us to look like this. We have to be very careful putting this onto the number line. There's a lot of weird little details behind that. So look at each one and put your dot in place, and then evaluate which of these three outcomes you'll have. So x is greater than 2. I need to put a dot at 2, and it's an open dot because there's no underline. And then x is less than negative 6. I need to put a dot at negative 6. Again, no underline. If x is less than negative 6, x is going to travel this way. If x is greater than 2, it's going to travel this way. So in this case, you have a divided set. They go opposite ways. X is less than a very small value, and or it's more than a very big value. If x had been less than 2 and greater than -6, so had the signs been opposite, you would have had a center region filled in. These are obviously very tricky, but I strongly encourage you not to think of them as being overly hard. They're just a couple of extra rules that you have to follow in tandem with each other in order to not have any mistakes happen. Again, try these a couple times. I would go back to the absolute values and the inequalities first, then cruise back to the combination of the two. This is typically one test question that would be it's never an absolute value alone or an inequality alone. It's the two of them combined. They are not overly difficult, but if you are having trouble with it, it's probably not worth your battle, which is why I don't give it a whole lot of class time. That's why we rushed the last couple of examples, is it's not as worth your class time as the other things we looked at. Let me know how that goes. Let me know if you want any help on it, if you want to abandon it, as long as you're not trying to get, let's say, an 88 or higher. It's fine to purposely abandon a particular question. If you're trying to get 90 or higher, I wouldn't recommend abandoning anything. But let me know, and let me know what you think. I have General Science 1 coming up next. I will be sending out the invite shortly. If you do want to come to that one, let me know, and I will see you guys later. Thanks.